Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 904, Fruit into Baskets. This is a medium difficulty Leetcode problem, and the problem description tells us that we're visiting a farm that has a single row of fruit trees arranged from left to right. The trees are represented by integer array fruits, where fruits I is the type of fruit the ith tree produces. And we want to collect as much as fruit as possible. However, we're told that the owner has some strict rules that we must follow. And these rules are that we can only have 2 baskets, and each basket can only hold a single type of fruit. And there is no limit on the amount of fruit each basket can hold. Starting from any tree of our choice, we must pick exactly 1 fruit from every tree. So if we've started from a tree, for every single tree, we can't skip a tree, we must, for every tree, pick exactly 1 fruit. While moving to the right, and the picked fruits must fit in one of our baskets. So if we have 2 different types of fruit that we've been storing in each basket, and we come across an outlier, a banana as opposed to a pear and an apple, well then that's not good. It won't fit in any baskets, and so we won't be able to return that list. So once we reach a tree with fruits that cannot fit in your basket, we must stop. So that's the key word there. Stop when we reach a fruit that cannot fit our baskets. And given the integer array fruits, return the maximum number of fruits we can pick. So we're going to be given an integer array of fruits where each number represents a unique type of fruit. So the tree of which fruits can go on, basically. So what is this problem telling us? Well, simply put, what it's telling us is we want to find the longest contiguous subarray that contains at most 2 different types. So simply put, the longest contiguous subarray that contains at most 2 different fruits, 2 different types, 2 different types of fruit tree, but no more. So in this example, we can pick from all 3 trees because there are only 2 different types. In this example, we can pick the trees 1, 2, and 2, and this gives us the most fruit that we can actually pick. If we started at 0, for example, we could only pick 0 and 1, and once we got to 2, we would have to stop. So this is the best answer. And if you haven't spotted already, this is basically a textbook sliding window problem. So how are we gonna solve this problem? Well, we're gonna have a hash map which stores the count of each tree, and how many times it appears in our window. And if we have more than 2 fruit trees, well then we know that we need to now shrink our window so that it contains at most 2 different types. So let's actually get to coding this up. The first thing I'm going to do is create a count hash map, a count dictionary, result which is going to be equal to 0, and left which is going to be equal to 0, left pointer. We're going to say for r in range length fruits. Now what do we want to do? We want to increment our hash map with a count. So we want to say count, get the fruit at pointer r, get the type of tree at pointer r, sorry, equals count.get, and then we want to get fruits are 0 is going to be the default value. We're going to increment it by 1. And we're going to say while the length of count is greater than 2, we want to shrink our pointer. So we want to say count fruits are minus equals 1. And if, actually that's incorrect, it should be at the left pointer, minus equals 1, because that's what we are basically shortening our subarray from. It's going to be, the window is going to be shortened from the left hand side. And if this ends up equaling 0, well then we just want to delete it from our count. So delete u, and then we can simply just increment our left pointer by 1. We'll keep doing this until we are back to no more than 2 different types of fruit trees in our subarray. And then we can then set the result equal to the max of the result, as well as r minus l plus 1. Make sure we get the entire size of our window, and then we can simply return result. Let's submit our code. And we can see that we passed all 93 test cases for this problem. So in terms of time complexity, guys, well, we're looking at a big O of n time complexity. My drawing is terrible. And big O of 1 for space complexity. So I hope you guys enjoyed this video. Very fun, very fun sliding window problem, actually. It's disguised, and it can be a bit confusing when you read all of this description over here. But once you understand the intuition behind solving it, it's a fun problem to solve and really quite simple. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.